So today we are going to start with the TCP Intercept. So what it is, basically, if you remember the very first class, I told you that we have basically three types of traffic, right? The first, I told you that we have something called control plane. Control plane is basically when a machine is generating the traffic for another machine. Then I told you that there is something called management traffic. And what is management traffic? When a user is generating a traffic for a machine to access it, right? And the third was data plane.
Data plane.
A data plane means when the user is generating the traffic for another user, or when a user is generating a traffic for a server. Okay. So again, coming to the fact, what is the purpose of TCP intercept? So the TCP intercept is basically a feature or is a solution that is designed to secure your data plane traffic. Okay, so basically the TCP intercept feature has been designed to secure your data plane. Okay, now talking about where you can implement this feature, you can implement the TCP intercept feature only on Cisco routers. Fine, you cannot implement the TCP intercept feature on the switches. Fine. Next thing, before concluding that how we implement the TCP intercept, what is the logic behind TCP intercept? First of all, we would like to understand what are the problems and how does TCP intercept resolve those problems. Okay, so I hope everyone is aware of TCP protocol, right? So TCP protocol is something which we say that it is a connection oriented protocol. Connection oriented protocol means that before sending the actual data, okay, the TCP protocol makes sure that there is connectivity between the two machines. And how does it happen? It happens with a process which is known as three-way handshake process, right? So what happens in this three-way handshake process? Let's suppose that's the client machine, or that's another client machine, or you can just call it a server, right? So what happens? First of all, the client will send a synchronized message to the server. The server will respond back with the synchronized plus acknowledgement message. Finally, the client will respond back with the acknowledgement message. So once the three-way handshake is successful, once the TCP connection has been established, this is TCP connection. So once the TCP connection has been established, then the user data is being transferred between the two devices. Right? That's why we say the TCP protocol is more convenient and more reliable than the UDP protocol. Now, talking about this TCP intercept feature, as the name says, the TCP intercept feature is something which is related to the TCP protocol only. Okay, so that means if there is any communication which is happening on the using the UDP protocol, the TCP intercept feature is not going to help you out. So this TCP intercept feature is only going to help you out when the user is communicating with another user with the TCP protocol, or user is communicating with the server with the TCP protocol. Fine. Next thing.
Prashant, before
Yes.
you starting, I would like to confirm here.
Mm-hmm.
Understanding the TCP is here. The TCP and Intercept basically work on those protocols which comes under TCP, right? Like HTTP is
Absolutely.
like
HTTP, HTTPS, Telnet,
Telnet,
SSH,
SSH,
right?
whatever the protocol comes under TCP, it is going to secure it. It
Yes,
basically TCP Intercept is that, right?
absolutely.
Okay.
Okay. So basically, this TCP intercept feature is again is only going to secure you, is going to provide a way of security for the TCP based communication, but not the UDP based communication. Okay. Now talking about uh, how does it help? So let's discuss the problems. Okay. So in a very layman language, I would like to introduce a problem which is known as TCP half open connection. Okay. So what is TCP half open connection? Basically, that's a problem in our network. How does it happen? Let's suppose we are having a PC. That's my server. Okay. That's my router. This router is further connected with another router, and then this there is connectivity with this server. Okay. And with this router, we are having a switch is further connected with some number of users. So considering a fact, let's suppose these two are my legitimate users. Okay, that means these users are my authentic user, while this user is something you can call it as an attacker. Fine. Now, what usually happens, let's suppose that this user, there is on this server, let's suppose this is an HTTPS server, fine. And this server is hosting a website, www.abc.com, fine. So now what happens, whenever you are going to open the Google Chrome on your system, you will write the www.abc.com. First of all, your system will resolve the DNS. There will be a DNS query between the server and the PC. Then your user will send a, then your user, basically the user machine will try to set up a TCP connection. So in this TCP connection, the user PC will send a synchronized message to the server. The server will respond back with the synchronized plus acknowledgement message. And finally, the end user machine will send an acknowledgement message. Once the three-way handshake is successful, only then the HTTPS traffic will be sent, or you can say the HTTPS traffic will be exchanged between the two machines, right? Now, let's suppose that that's your company. Okay, just assume you are the owner of this company, and let's name this company as gomama.com. Okay, so basically this organization or this company provides the domain name, this provides the server where you can host your website, fine. Now what happens, let's suppose that you are the owner of this company, and you know that multiple clients are going to access this website www.abc.com, and whenever they want to reach the www.abc.com, they will reach to this server only. Okay, now obviously when there are some legitimate users, there might be some unethical users, right? Now assuming a scenario, let's suppose that this attacker this let's suppose this attacker, it sends a synchronized message to the server. Okay, now obviously the server will respond back with something called synchronized plus acknowledgement message. Now since this attacker has the intention to bring your server down, it does not have any intention to steal the data or to have a proper communication with your server, but instead the attacker has the goal to bring your server down. That means if any legitimate user will try to access the server, they will get the message that the server is not available or the website is down. Now, what this attacker is going to do, it will send the synchronized message. The server will respond back with the synchronized plus acknowledgement message, but the attacker will not respond back with the acknowledgement message. It won't. Okay. So now what happens in such a scenario, when the three-way handshake process is not completed, such connections are known as TCP half open connection. And TCP half open connections are problem for your servers. Okay, why does it happen? We'll come to know in today's class, but just for an understanding, the attacker has sent a synchronized message, server has given a reply back, but finally the attacker machine has to give an acknowledgement back, but no acknowledgement has been sent. So now what is the problem? The problem is that whenever your server is going to receive a request, okay, it will open a connection. Basically, I would like to relate it like this. This is your router R1. You are the admin. There are multiple admin connected with the routers. Okay, that's your switch. You have configured line VTY 0 to 2. I hope now everybody understand that line VTY 0 to 2 means that how many users are allowed to take the telnet or the remote access. 3 users, right? There is something called line 0, line 1 and line 2. So what happens exactly? The line 0 is basically reserved for the console access. Right. Now, line 1 and line 2 are there. Let's suppose that that's an attacker within your company and he has sent a request to the router that he would like to take the telnet. And the telnet is TCP based protocol, right? So the attacker will send a synchronized message, and then the server, or you can say the server is connected here, it will respond back with synchronized plus acknowledgement. And now the attacker will not respond back with the acknowledgement message. Now the problem is this router, which is acting as a telnet server here in your scenario, it has opened a connection on the line VTY1. Okay. Now let's suppose that this attacker is sending again a request with a different IP. Let's suppose that the first request has been sent with the IP 10.1. With the help of IP spoofing, the attacker is sending the next request with IP address 20.1. Now with the 20.1, again it will send a synchronized message. Sync plus acknowledgement message will be revert back. Attacker will not respond back with the acknowledgement. Now in this scenario, line 2 will be reserved. Now the problem is, if this legitimate admin will try to access the telnet protocol, or you can say that when this admin will try to take the router, the line VTY access is completely occupied. So it will say denial of service. The router will say that the service is not available. It is going to deny it. Why? Because it is already being occupied with its full efficiency. Okay. And that's why this is something called DOS attack. DOS is what? Denial of service. So why does it happen on the server? When the servers are basically receiving so many requests simultaneously, and once all the requests, or you can say once all the connections have been fulfilled, have been completely occupied, then all other users will not be able to access this server. Why? Because the connections are already being occupied. And this is the problem. Okay, and that is why I'm saying the TCP half open connections are the problem in real-time network. Is it clear to everybody? Any queries, please let me know.
Hi, Prashant.
Yes.
I just want to confirm that can you scroll down the
Yes.
server? If the service is publicly hosted a service, then what will be if line VTY 1 and 2, the two people are already occupied the connection, right? So how will we can access if the service is publicly hosted on the server?
See, when you talk about the real-time scenario, okay, the servers basically work on a different concept. The servers do not work on the concept of line VTY. I'm just giving you an example that whenever you configure telnet protocol on the router, basically it is acting as a telnet server. Once the line VTY has been completely occupied, the legitimate user will not be able to get the access. Similar is the case with the servers also. Just hold on. Let me just explain.
Okay, sure.
When it comes to the concept of the servers, every server, whenever you are going to purchase a new server from the market, there are some specifications, okay, and every server is going to have certain number of concurrent sessions. In fact, your firewall too, if anyone has worked on the firewalls, you will notice something called concurrent sessions and the total sessions. Okay, so concurrent session means how much number of sessions a router, or you can say, or a firewall can handle at a time. Similar is the case for a server also. Okay, whenever you are going to purchase any server, let's suppose the server has the capability of holding 500 connections. Okay, that's the total possible connections. So there will be something like C1, connection 1, connection 2, connection 3, connection 4, and so on, like C500. Fine. Then we have a switch. Then that's your router. That's your customer edge router. Then this is your ISP. And then as a user, you are having multiple users. Okay. Now what happens? Let's suppose this is having the IP 10.1, 20.1, and 30.1. Now, this is an attacker. When it will basically the whole purpose is to bring the server down or to have a denial of service attack so that the legitimate user cannot have the access of the server. So what it is going to do, basically he will use the IP spoofing. Along with the IP spoofing, what he can do, he can generate number of requests in 1 second. So with some unethical tools, the attacker is he will not only be sending the request. Let's suppose the server IP address is 100.1. okay, so this attacker will send the source, the destination IP will be, let's suppose 30.1 at a time. The destination IP is 100.1, source port number random, destination port number 443 for HTTPS. Again, he will send a new request within different IP. With the IP spoofing means this is not the actual IP of the device. Let's suppose it is 30.2, destination IP 100.1, source port number random, destination port number, and within 1 second, the attacker will be able to generate thousands, or you can say the lakhs of requests simultaneously when all the packets will be forwarded to the server. So let's consider a scenario where the server has the limitation of holding only 500 connection, and let's suppose the attacker has generated 1000 requests. So obviously all the connections will be occupied, and when this legitimate user will try to access, they will not be able to access. Now coming to the fact how as an admin I can access. Okay, so right now I'm talking about the remote access. Let's suppose you are the admin of the server. So when I talk about the admin of the server, you can take the access using the console port, and on the console port you will always get the access. Why? Because the console access is the access of the console port is only available through the console cable, and it will never be occupied until and unless someone within the network physically present on the appliance and he is taking the access. Clear to everybody?
Yes.
So let's proceed further. So basically with this TCP intercept feature, I'm just trying to protect my server. Okay. So basically, I'm just trying to protect my server with the help of this TCP intercept feature. And when a user send a request, when a user send a packet to server, it is nothing. It is just the data plane. And why I am calling it securing the data plane? Just because if your legitimate users will not be able to access the server, okay, then what's the point of having such server, or what's the point of having such communication? So basically your whole purpose is that your attacker should be blocked, okay, and the legitimate user should be able to access the service, or you can say the server. And that's why we came up with the feature, something called TCP intercept feature. And in the beginning of the session, I told you clearly that feature, TCP intercept feature, is basically designed only for the Cisco routers. Okay. So basically, if you are having a small scale organization, okay, where the company is having a low budget, still they would like to implement some sort of security for their servers, you can just configure some features like TCP intercept. However, it is not the ultimate solution. The ultimate solutions is DDoS protections, the NGFW, IPS. These are the ultimate solutions. Router is not meant to provide you security. However, the router can do this at some extent. Just assume this in a scenario. Let's suppose you are working in a company where you have been hired as a network engineer, okay? But let's suppose your manager, who is quite cunning, he asks you to make an Excel sheet, okay? However, you know as a network engineer that that's not your KRA, but still you will do this, right? Because that's your manager, or you can say that's your customer demands it. In the similar manner, the router is specifically meant to provide the routing, but it can provide you some extent of switching also. If all of you are aware of inter-VLAN routing, guys, do you remember within the inter-VLAN routing, you create some SVI on the routers,
SVI on the router,
and you define the
encapsulation
.1Q authentication.
Yeah, encapsulation .1Q,
right? That means your router is performing the switches. Also, I can you talk about the spanning tree protocol. The spanning tree protocol is only configured on the switches. I can configure the spanning tree protocol on the router also, and I can generate the BPD. This is what I can do. This is we all can do. That means a router does have a function of routing, but it can perform the other task of switching and provide some bit of security. Similar concept goes for the firewall too. The firewall is specifically designed to block or permit the traffic based on the policies. But however, the firewall also perform routing. The firewall can also be configured as a switch. And we will discuss this thing when we will configure Cisco OSA.
It can also be a load balancer.
Right, absolutely. So basically on a single appliance, you can have multiple features. But the point is, the sole purpose of the appliance is not to provide you security, but the routing. Similarly, firewall has the main purpose to provide you the blocking of the traffic based on the policies. Okay, it is not meant to perform the switching, but you can do that at some extent. I hope everybody is clear till this point. Any queries?
No.
Miss Athira, Santosh ji, do you have any queries, sir?
No, it is clear.
Thank you. So let's go ahead. So to discuss TCP half open connection problem and how to resolve it, we are going to configure TCP intercept feature on the router. For that, I need to design the topology, and I'll take GNS to perform this practical. So we'll take 3 routers to perform this practical: R1, R2, and R3. Done. Now you can turn on all your devices. So this device is going to have the IP 10.0.0.1/24. This device is going to have the IP on this interface 10.0.0.2/24. On this particular interface, I will configure 20.0.0.2/24. And on this interface 20.0.0.2, sorry, 1/24. Done. So these will be the IP addresses that shall be configured on these particular interfaces. So these are the name of the interfaces. So let's start the configuration. On the R1, configuration terminal interface is 0/0. No shutdown. IP address will be 10.0.0.1, 255.255.255.0. That's it. Move to another router. That's R2. Configuration terminal interface of 0/0. No shutdown. IP address 10.0.0.2, 255.255.0. Interface F1/0. No shutdown. IP address will be 20.0.0.2, 255.255.255.0. That's it. Finally, move to router R3. Configuration terminal interface F0/0. No shutdown. IP address will be 20.0.0.1, 255.255.255.0. Now to have end-to-end reachability between these routers, because we know by default your router is going to have directly connected network in the routing table. So I need to enable some routing protocol. So let me enable EIGRP. So router EIGRP 1, network 0.0.0.0. Let me enable the EIGRP protocol on all the interfaces. Do show run pipe section EIGRP. So we'll copy paste these commands and we'll implement on other routers too. Copy, paste. Done on R2. Similarly, move to R1. Done. So now if I check the routing table of R1, do show IP route. You can see the router is having a network of 10 directly connected and the network of 20 have been learned with the EIGRP protocol. Same goes with the router R3. Do show IP route. So let's ping from R3, do ping 10.0.0.1. So there is end-to-end reachability between all the three routers. Now we'll start the practical. To start the practical, what I'm going to do, I will configure the telnet protocol on router R3 because telnet protocol is TCP based protocol, right? So move to router R3. How do we configure telnet? Line VTY 0 to 4, transport input all, then no login. That's fine. I have configured the telnet protocol on router R3. Now just check on the router R1 if you are able to take the telnet or not. Do telnet 20.0.0.1. Yes, we are. You can see. That's it. Now, let me explain you the theory of the practical which we are going to conclude in today's class. Print screen. So I'm going to perform this practical with two different cases. Okay, so that's my case one. That's my case one. When considering the fact this is your user, or just consider that this is your legitimate user, okay, and that's your server, which is holding any website or any TCP based communication. Because when you are going to take the telnet from this router to router R3, the communication will be TCP based, right? So that's why just assume that R1 is your user and R3 is your server. Okay, now, and I'm considering that this user is legitimate user. Fine. Now, I'm going to enable this TCP intercept feature on my router. Now, in your scenario, you can consider that this is your customer edge router. Customer edge router means this router belongs to your organization, while this server is in your any public server, whatever it is. Okay. So what I'm going to do, I will enable TCP intercept feature. Okay. Now, so what TCP intercept feature does? Let's suppose this user R1 has sent a synchronized message. In this synchronized message, what will be the source IP? It will be 10.1. What will be destination IP? It will be 20.1, right? Because the router will try to take the telnet of 20.1 only. What will be the port number? The source port number will be random. What will be destination port number? It will be 23. I hope everybody is clear with this. Now, since you have enabled the TCP intercept feature on the router R2, so it will not send this synchronized message directly to the server. It will not. But instead, this router will generate a packet called synchronize plus acknowledgement message, and router will generate this message on the behalf of server. Is it clear? Basically, the synchronized message has not been sent by this router to the actual server. It will keep this packet to itself, and it will generate a packet, reply packet on behalf of this router, or you can say on the behalf of the server. So when this R2 will revert back, it will revert back with the source IP 20.1, destination IP 10.1, source port number will be what? 23, and the destination port number will be random, which has been used here. Clear? Now, since this is a legitimate user, so obviously it will revert back with the acknowledgement message. The source IP will be 10.1, destination IP will be 20.1, source port number will be random, destination port number will be 23. Now, once the three-way handshake is completed, your router will come to know that this user 10.1 who is sending me the request for this server is a legitimate user. Okay, so what this router is going to do now, he will send a packet on behalf of, just wait. So basically you can say this is your first half of TCP connection. Why I'm calling it first half? Because this TCP connection is successful, but with a medium device, okay, the mid device, but not with the server. So now this router, since it is enabled with the TCP intercept feature, he has noticed that the three-way handshake is successful. So router will believe that this user is authentic, he is legitimate user. So now this router will send a synchronized message on the behalf of this user now. So the source IP will be 10.1, destination IP will be 20.1. He will send a with the port number random. This random port number will be same which has been used by this user actually. Okay. Then the server will respond back with synchronize plus acknowledgement message. Finally, this R2 will revert back with acknowledgement. And again, he will revert back on the behalf of user 10.1, 20.1, random port number 23. Now, in this case, once you can call this as second half of TCP connection. Okay. Once your core router where you have enabled the TCP intercept feature, now he has checked that the three-way handshake is successful from the user end, three-way handshake is successful from the server end. So now finally what this router will do, it will connect, it will make the connection finally, and when this user will try to send any packet to the server, it will directly forward to the server. Is it clear? That's the case where the three-way handshake is successful. Is it clear to all of you?
Yes, yes.
Tarun, any queries?
TCP intercept, how are we going to configure it here?
We will I'll configure, I'll show you the commands, don't worry.
And again, did we get any syslog messages stating
Yes.
that
Yeah, see, you will be having certain tables where you can check. Even I will show you the debug commands to prove this.
how if we are attacking, if we are getting those attacks, and how would, is there a possibility with the TCP intercept, does it have a feature that it will make us alert on the like this has been attack, or like it is
I'll show you while performing the practical.
okay.
Okay, so let's perform this practical with considering the fact that my user is legitimate. Okay, then I will perform the second practical with case 2 where I will consider my user is not legitimate and the TCP connection is not complete. It's basically TCP half open connection, and then we will perform the practical with the TCP intercept. Okay, so let's move to our scenario. Right now you have seen. Okay, just hold on. Let me run this command on router R3. Do debug TCP packets, so that just to make do debug IP. I think the problem with do debug TCP packet. IP TCP packet. Fine. So I have enabled this command on router R3, which is your server. I have told this R3 that whenever you are going to receive or whenever you are going to send any packet related to TCP, please send me the log message. Fine. Now, coming back to the router R2. Okay, just hold on. I will enable this do debug TCP, do debug IP TCP packet. Fine. Done. Now, that's your R2. That's your R3. And let me take the R1 also. Okay, so that's your R1, R2 and R3. So now let me try to take the telnet from router R1, that is from the user. Okay, so let me just change the host name user R1. Done. On R3, host name server R3. Done. Now let me try to take the telnet from the user to the server. Telnet 20.0.0.1. You can see I am able to take the access. Now, did you see any log message on the router R2? Even though I have run the debugging command, just because this debug packet will be shown by the router only when the packet is actually meant for this router R2 only. Since the synchronized packet which has been sent by the router R1 is actually for router R3, that's why it is not showing you the log message. However, if you see the log message on the R3, see, it has received the sync packet from 10.1 having this source port number for this destination IP and this port number. Is it clear? So you can see these couple of handshake process. Also, what I can do, I can just enable the Wireshark between R2 and R3, start capture, and then start Wireshark, move to router R1, exit. Let me close the session again. Fine. So let me try to take the access from R1 again, telnet 20.0.0.1. You can see on the Wireshark, three-way handshake process, synchronize, acknowledgement, sync plus act, and then acknowledgement message. Fine. Now, right now, your router R2, is he maintaining any table? Is he providing any security feature? No. Okay. So now you would like to secure your R3. Basically, you would like to secure your server. So now I shall enable the TCP intercept feature so that your router R2 will monitor the connections. Okay. And how does it happen? See, first of all, step one, that you need to create ACL and you need to define which traffic should I monitor. Okay, that means you need to tell the router that which traffic you should monitor. Okay. Can I request all of you to just hold on for a second? I'm getting an important call.
Yeah, sure.
So first of all, you need to create an ACL on the router and you need to define which traffic the router should monitor. So how you can create an ACL? IP access list extended. Okay, and let's name it. Let me name this ACL as ABC, and then which traffic I would like to monitor. You need to, since I want my router R2 should monitor all the traffic which has been initiated by 10.1 for the destination 20.1 for the port number 23. Okay, let's suppose this traffic I would like to monitor on my device. So I will create the ACL similarly. So permit TCP. What will be the source IP? It will be 10.0.0.1. What will be the destination IP? It will be 20.0.0.1 on the port number 23. Is it clear to all of you? I just have created an ACL. That's your first step. Then step 2. Step 2 is you need to enable TCP intercept feature. Okay. Now, how you can enable the TCP intercept feature on your router? You can run this command IP TCP intercept, put question mark, and it says list. Specify the list to use. Okay. So I will write list, put question mark. It says, please define the name of the access list. What is the name of my access list? It is ABC, right? That execute this command. That's it. That is it. Now, let me just remove this connection. And now the TCP intercept feature has been enabled on your router R2. If I run this command, show IP TCP, show TCP intercept connections. Do you see any connections as of now? Because there is no TCP packet flowing through this router R2. Okay. if I run this command, show TCP intercept statistics, okay, it says that I am intercepting the traffic. I am monitoring the traffic based on the access list. So this access list, whatever you are going to configure, only that traffic will be monitored. Now your router says that right now 0 incomplete connection. Incomplete connection means TCP half open connection, and 0 established connection. Is it clear? Now let me move to my router R1, okay, and let me try to take the access again. Telnet to 20.0.0.1. The telnet connection is there. Now if I run this command on router R2, see, show TCP intercept statistics, it says 0 incomplete connection, but there is 1 established connection, right? And if I run this command, show TCP intercept connections, it says there is 1 established connection having the source IP 10.1 with this port number to the destination IP 20.1 with this port number. State is established, okay? And you can see the incomplete connections are nothing because there is no TCP half open connections as of now. Clear to everybody? Now, I would like to show you the theoretical thing which I have explained you. I told you that first of all, when your user will send the synchronized message, the router will send the revert on behalf of this server, right? It will not send to the actual server. Once this half open connection is successful, first TCP connection is successful, then it will create the second TCP connection, and finally it is going to bind it. And let me prove this. So what I can do, guys, let me just exit this connection. Let me run a command on router R2, debug TCP intercept, just hold on, debug IP TCP intercept, okay? So I have made the debugging on. So let me try to take the telnet connection. You got some couple of log messages, okay? And now let me just copy these log messages to explain you. Copy. So these were the log message you receive on the router which is configured with the TCP intercept feature, right? So if you just read these log messages, you will notice something. The router says that a new connection request have been received where this is the source IP, and a synchronized message has been sent by this source IP to the destination IP 20.1 for this port number. Is it clear? Now your router says that 20.0.0.1 has sent an acknowledgement plus synchronized message. You can see this arrow. This arrow signifies that this packet has been sent by 20.1 to 10.1. And here your router says the TCP first half connection has been established. Why? Because 10.1 has reverted back with the 20.1 to the 20.1 with the acknowledgement message. So first half of the TCP connection has been established, right, guys? Then the router says, I will send a message with the source IP 10.1, and you can see this port number is the router R2 is using the same port number, random port number, right, to the 20.1. Now it says the client dropped the packet, might be due to some line protocol, it has dropped the packet, but it says, see the next packet, it says I have received the reply from 20.1, and now the 10.1 has reverted back to the 20.1, and finally here you can see it says the second half of the connection has been established and the connection is successful. Is it clear? So basically here your router R2 is monitoring the traffic. If I run this command, show TCP intercept connection, you can see the connection has been established 2 minutes ago. And what is this timeout? timeout, see, by default timeout means 20, by default timeout is 24 hours. That means if the router will keep this connection as it is without doing anything, so router will remove this connection after 24 hours. Is it clear? But if you will run any command, if you do any activity, this timeout will be refreshed. You can see it is 23, 59, 56. Let me execute this, start, enter again, and you will notice it is 58 because I am entering here. Is it clear to all of you? So once you do any activity with the server, the timeout will keep on refreshing. If you will not do any activity, if the mode is idle, if you are not doing anything, so after 24 hours, by default, this router R2 will break the connection. Is it clear to all of you?
Yes.
Hello. Yes.
Yeah, it's clear. Okay, Ben, are you clear with this?
Can I ask you?
Yes, I'm
this is
good.
Yes,
default.
please tell me. Athira, are you having any query?
Yes.
Please
Actually, I just want to know that the 24 hours is default time
Yes.
for the server connection,
Mm-hmm.
or we can set the time.
Yes, obviously we can manipulate it. I'll let you know at the end of the session. Okay.
Okay. Thank you.
That's it. So this is the case with the legitimate user. Okay, that's what I have explained. Now we will discuss the same case with the unethical user, and for that let me just take a break of 3 minutes, and we will resume the session at 10:43. Okay.
Okay.
So now we shall talk about the second case. Okay. So the second case is we are going to consider that the user is not legitimate. Okay. So basically it is an attacker. Fine. So what happens? Again, I'm going to divide this whole communication in two ways. Let's suppose this attacker sends a synchronized message, okay, with the source IP 10.1, destination IP 20.1, with the source port number random, destination port number 23, right? Now, as I told you that R2 will not send this packet, right? Because you have enabled the TCP intercept feature. Now, R2 will send a reply back on the behalf of the actual server. Synchronized plus acknowledgement message, source IP 20.1, destination IP 10.1, source port number 23, destination port number random. Now, since this user is an unethical user, it's an attacker, so obviously it won't revert back with an acknowledgement message. Now the router R2 is in monitoring mode, right? It is intercepting the traffic, it is monitoring the traffic. So basically R2 will send the synchronized message again, synchronized plus acknowledgement. It will again send the synchronized plus acknowledgement based message. So basically your router R2 will send the synchronized message again and again 5 times. Is it clear? And even after sending the synchronized plus acknowledgement message 5 times, if this R2 didn't receive any response, or if you can say if the R2 didn't receive any acknowledgement message, then finally it will send an reset message. It will send, router R2 will send a reset message to R1 that I would like to break the connection, because your router has sensed that this is not a legitimate user, because the TCP connection is half open to me. Is it clear to all of you?
Yes, please.
Miss Athira, any queries? Santosh ji, Tarun.
Yes, basically, I would like to understand again, please.
So basically the point is, Tarun, if the router R2, okay, basically he will check whether the three-way handshake is complete or not, right? So if it is not a legitimate user, he will send the synchronized message. Obviously the router will revert back with synchronized plus acknowledgement message on the behalf of the server. Now, since it is an attacker, it will not send the acknowledgement message. Now it becomes your TCP half open connection. Now, in such a scenario, your router R2, which is enabled with the TCP intercept feature, it will send the synchronized plus acknowledgement packet message 5 times. Okay, even after sending the synchronized plus acknowledgement message to the source, okay, to the source from where the packet synchronized packet has been received. Even after that, if the router didn't receive any acknowledgement message, okay, then the router will send, finally it will send a resend message, assuming that it is not a legitimate user. So it will break the connection. And in such a scenario, your router, your server basically will be saved from TCP half open connection. Tarun, clear?
Clear.
Okay. So let's do this practical. Wait. So basically what I'm going to do, I will request the telnet to 20.1 from router R1. R1 will send a synchronized message. Okay. And I will create an ACL here. And I will tell router R1 not to receive any packet which is carrying synchronized plus acknowledgement message. That's it. So that means when this R2 will revert back with sync plus package acknowledgement, R1 won't receive this. If R1 won't receive this, R1 will not send any acknowledgement message. It will become the TCP half open connection, and then we will see how the TCP intercept feature works. Is it clear now? Tarun?
Clear.
Yeah, it's clear for me.
So let's move to router R1. Move to the global configuration mode. Let me create the ACL IP access list extended, and let's name this ACL as DEF. Okay, and since now I would like to block the communication which is actually the synchronized plus acknowledgement message, right? So what I can do, deny TCP packet from any source having any destination and packet is carrying synchronized and acknowledgement message. That's it. I have told my router that you need to deny all the packet which you receive from any source, okay, having any destination, and the packet is carrying TCP synchronized and acknowledgement message. You need to deny it. That's it. Clear to everybody?
Yes, please.
Okay, fine. And then I will permit rest of the traffic. Why? Because EIGRP protocol is also running. If I don't run this command permit IP any, then it will block all the packets. Exit. And now I will implement this interface as 0/0 IP access group DEF in inbound direction. That's it. Now, since this debug TCP intercept command is already running on your router, so let me run this command: do telnet 10.0. Do telnet 20.0.0.1. You can see that the router R1 is not able to get the telnet. And just hold on, just wait for the log messages here.
Only 3, 4.
wait. You got the reply finally? And as the, now let's just match with the theoretical stuff that I told you. Just wait. Okay, I told you that first of all, the router R1 will send the synchronized message. R2 will revert back with synchronized plus acknowledgement. And then if R2 do not receive the acknowledgement message, then it will try to send the sync plus acknowledgement message 5 times. And you can see here. Let me just conclude this activity again, because we are not able to read the logs. Just hold on. Move to R1. Let's take the telnet access again. That's it. Just wait. And let me run this command. Show TCP intercept connection. Here you can see it says there is some incomplete connections. And if I run this command to show TCP intercept in static, it says there is one incomplete connection. Okay, just wait. You can see the timeout here also. And now see, first of all, the router has initiated a connection. The router R2 says that I got a request from 10.1 having the source IP 10.1 to the destination IP 20.1. Now the router says I have sent a request from my side, but the router did not receive any request. Now the router says I am trying to retransmit again. Then this is the second attempt, third attempt, fourth attempt, fifth attempt, and finally your router has sent a reset message to the that I would not like to form the TCP connection with you. You can see, and when I run this command, show TCP intercept connections, you can see your router says there is an incomplete connection here. Is it clear to everybody that this is how the TCP intercept feature is saving your server from the TCP half open connections, or you can say somewhere a DOS attack? Mr. Ben, any queries? Tarun?
No, I'm good. You've clarified it, so.
No, good. We are good.
Santosh ji?
One question,
Yes.
Prashant. Basically, what I wanted to know is that in the real world, we don't use this TCP intercept, right?
Tarun, see, right now all of your queries are related to the organizations which are actually very wealthy organizations. Okay. Right? You need to understand this thing. Where does this firewall has been evolved? What prerequisite or what circumstances or what problems has led these Cisco organizations?
No, that I understand. That previously I should be aware that this right. has happened. That's the reason this has been created. Right. That I understand, and I am not denying with this part that it right. there was a topology or technology like this. Then that's the and this attack happened. That's the reason they have created a high end technology further. But what my question is, why I wanted to regenerate this question just to ensure that high-end things are there based on this concept.
Absolutely.
Okay.
Why? See, when we will discuss the Cisco firepower or the Cisco ASA, I will show you the connection table. Okay. So because every appliance, whether it is Fortinet firewall or the Sophos firewall or the Cisco
for the Palo Alto, what do we do? We have any kind of
yes, I would like to tell you that all of the next generation firewalls are maintaining something called connection table. Okay,
connection tables.
So if they are receiving the connection, if they see that there is any half open connection, they will do the same thing.
Okay.
So just I would just like to tell you that you can do all these things on the Cisco router also, but that's not a security. The router is not meant for the security plans. However, if you are having a small scale organization, you can achieve all those things with the router too. But again, that's not a purely security appliance. And similarly, when we will go to the next generation firewalls, you talk about any OEM, they maintain something called connection table, and the main purpose, or you can say the main basics of the connection table is what I have explained you in today's class. Basically, the firewall is going to monitor the traffic that is passing between the two devices. If the firewall monitors that there is some TCP half open connection, or if the router or if the firewall experience that there is a source IP which is sending the TCP connections again and again, but it is not establishing a complete connection, your firewall will immediately block that IP, right? So this is all just the basic fundamentals from where the next generation firewalls, or you can say the traditional firewalls, are being working.
Understood, very much understood. With the situation. And is there a possibility of blocking, having this intercept configured onto the router 3 as well?
On router 3 as well?
Yes.
Basically, in our scenario, we are considering this router 3 as a server. However, if this is your router, you can configure it, obviously. But just to demonstrate this practical, I'm considering that this is my only router, that's my end machine, R1, and that's my server. I can configure this TCP intercept feature on the R3 itself also. But you need to understand this R3, this TCP intercept feature is not for the to the device traffic, but it is for the through the device traffic. Tarun, are you clear with this?
Got it.
Because for the when I talk about through the device traffic, this is TCP intercept feature, okay? But when I talk about to the device traffic, we have multiple features like Cisco iOS enhancement login feature, the login feature, the self-defense ACL, the quiet mode, which I have already explained you, right, in the previous classes. So that is something for the to the device. However, TCP intercept feature is for through the device traffic. Any more queries?
No, that's all.
Okay, so that's all from my side. Tomorrow, as I have already told all of you, that tomorrow someone else will be taking your session for the lab installation. Fine. And however, I will also be available in the session, but he will be leading the session and he will give you a complete demonstration how to install the lab. And I would request all of you.
EVNG or
EVNG only. Right now we are talking about the EVNG.